Hi everyone, welcome back. In this course, we are going to learn Python Pandas, one of the most powerful libraries for data analysis and data manipulation. If you want to work with the real-world data, clean it, analyze it, and extract meaningful insights, then this course is for you. We will start with the basics by understanding what Pandas is and how to install and import it in Python. Then you will learn about Pandas series and practice with exercises to build a strong foundation. Next, we will dive deep into DataFrames and understand how to create, access and manipulate data step by step. You will also learn how to handle missing data, which is one of the most important tasks in real-world data analysis. We will cover grouping and aggregation to summarize your data and filtering and sorting techniques to work efficiently with large data sets. You will also learn how to handle duplicate data and ensure data quality. Finally, we will work with files by reading CSV data into Pandas and writing processed data back to CSV files. By the end of this course, you will be able to confidently use Pandas to analyze data and solve real-world problems. Let's get started. If you are serious about data analysis, machine learning, data science, or even Excel automation using Python, Pandas is going to become your best friend. Let's begin with a simple question. What is Pandas? Pandas is a Python library used for data manipulation and data analysis. It provides us with high-performance, easy-to-use data structures, specifically series and data frame. Think of it this way. A series is like a single column from an Excel spreadsheet, and a data frame is like the entire spreadsheet with rows and columns. Using Pandas, you can filter your data, sort it, group it, clean it, aggregate it, and even visualize it. It's one of the most essential tools in the Python ecosystem, especially when working with structured data like CSV files or SQL tables. Now let's understand where the name Pandas came from. Pandas actually stands for Python Data Analysis Library. The name was inspired by the term panel data, which is a term used in econometrics for multidimensional structured data sets. The library was created by Wes McKinney in 2008 when he was working at a financial firm. He wanted a powerful tool to analyze time series and tabular data in Python. And that's how Pandas was born. Today, Pandas is maintained by an open source community and it's widely adopted by companies and developers around the world. Why should you use Pandas? Let's quickly discuss why Pandas is so popular. Number one, it gives you Excel-like power in Python. You can load large datasets from CSV, Excel, SQL, or JSON and perform complex analysis in just a few lines of code. Number two, it's super fast and memory efficient. Under the hood, Pandas uses a library called NumPy to store and process data, so it's built for performance. Number three, Pandas works beautifully with other libraries. Whether you are using Matplotlib for plotting, scikit-learn for machine learning, or SQL Alchemy for database connections, Pandas plays nicely with them all. Number 4. It has built-in support for time series data. This makes it ideal for use cases like stock market analysis, forecasting, and event tracking. Number 5. The documentation and community are outstanding. If you get stuck, chances are someone has already solved that problem on Stack Overflow or GitHub. So to summarize, Pandas is the foundation of data analysis in Python. It allows you to work with structured data just like you would in Excel or SQL, but using Python's syntax and power. In the next lecture, we'll install the Pandas library, import it into our project, and begin exploring it using simple examples. I'll see you in the next one. Hi everyone and welcome back. In the previous lecture, we introduced the Pandas library, why it's powerful, and how it helps us analyze structured data in Python. In this quick lecture, we will install Pandas, import it, and check its version by writing a code. Let's begin with installation. Pandas doesn't come built into Python by default. so we have to install it separately using the pip package manager. Go to Kykarm. Open your terminal and type this command: pip space install space pandas. Hit enter. Let the installation complete. It will download the pandas library along with its dependencies like NumPy. Once it's done, you are ready to import. Let's test the installation by importing it into the Python file. Let's create a folder and name it pandas. Let's now create a Python file. In PyCharm, right-click on pandas folder. Choose new, then Python file. Let's give the file a name, intro_pandas. Now, inside this file, we are going to write our first import statement. We type import space pandas space as space pd. This imports the pandas library and gives it a short alias pd, which is the standard convention used by Python developers around the world. So whenever we want to use any pandas function, we'll type pd dot followed by the method name. Let's now print a simple message to verify that our file is running correctly. We type print within parentheses, within quotes, say pandas imported successfully. Now let's run this file in PyCharm. Pandas imported successfully. Perfect. That means pandas is ready to use. Before we move further, it's a good idea to check which version of pandas we are using. We type print within parentheses pd dot double underscore version double underscore. This will show the version of the pandas library installed on your system. It might be a different version on your machine depending on when you install it, but as long as it's above version 1, you are good to go. Let's now summarize what we did in this lecture. We installed the pandas library using pip. We created a Python file inside PyCharm. We imported the pandas module using the alias pd. We checked the version. Thanks for watching, and I'll see you in the next one. Hi everyone, welcome back. In this lecture, we're going to learn about something called a Pandas series. This is the first and most basic data structure available in the pandas library. Once you understand series, it becomes much easier to work with larger data sets, especially when you move to DataFrames later. Let's start by understanding what a pandas series actually is. A series is basically like a single column of data. It's a one-dimensional labeled array that can hold any kind of data, integers, strings, floats, even Python objects. It's similar to a list or NumPy array, but the key difference is that a series has labels or indexes associated with each value. Let's now open PyCharm and create a new Python file. Right-click on the pandas folder, choose New, then Python file. Let's name it series_basics. Now inside this file, the first thing we need to do is import the pandas library. We type import space pandas space as space pd. This imports the pandas library and gives it a short alias pd, which is the standard convention used by Python developers around the world. Let's now create our first pandas series using a simple list of numbers. We say print within parentheses, then pd.series within parentheses, pass a list like 10, 20, 30, 40. Let's run this and see what happens. As you can see, pandas has automatically assigned index values starting from 0. So 10 is at index 0, 20 is at index 1, and so on. You can access any value by using its index, just like you would with a list. But here's the cool part. You can set your own labels instead of default numbers. Let's now create a new series, but this time we'll define both values and labels. Let's say we have marks for 3 students. Names are Alice, Bob, and Charlie. Marks are 90, 80, and 85. We type pd.series within parentheses, pass the list of marks 90, 80, 85, and then add a keyword called index equals and pass the list of names Alice, Bob, Charlie. We use the series class from pandas and passed 2 arguments, a list of values and a list of index labels. Notice here the second argument is the index, a list of strings Alice, Bob and Charlie. This means Alice gets 90, Bob gets 80 and Charlie gets 85. We're assigning custom labels to each value in the series. This is powerful because now we can access marks by name, not just by number. Next, print the series. Print within parentheses pass marks. Let's now run the program. You can see the output on the console. Alice 90, Bob 80, Charlie 85. Now we've got a labeled series. Instead of accessing by position, we can now access values using labels. Let's try to access Bob's score. We type series name within square brackets within quotes Bob. Let's now run the program. You can see the output on the console. 80. Perfect. Now let's see how you can add values to every element in a series. We simply type print within parentheses series name plus 5. Let's run the program. This adds 5 to each mark. 90 becomes 95, 80 becomes 85, and so on. This is called vectorized operations. No loop is needed. Let's now move on to some built-in functions. Let's say we want to calculate the average marks. We type print within quotes average marks colon, then add series name dot mean with parentheses. Run the code. This gives us the average of all the values. We can also calculate total marks. Type print within quotes total marks colon, then series name dot sum. Run the code. This gives the total marks. Finally, to find the highest mark, we say print series name dot max. Run the code. This gives the highest mark. All these functions are extremely useful when analyzing numerical data. A Pandas series can also be created directly from a Python dictionary, where each key becomes the label and each value becomes the data. Let's look at an example. Imagine we have marks for 3 students, Alice, Bob and Charlie. This time, instead of using 2 separate lists for names and marks, we'll create a dictionary. The keys will be the student names and the values will be their marks. Let's type student underscore marks equals to pd dot series within parentheses and pass a dictionary like this. Alice colon 90, Bob colon 80 and Charlie colon 85. Now let's print the series and see the output. Print and pass the series name student underscore marks. Run the program. On the console you will see Alice 90, Bob 80, Charlie 85. This works exactly the same as when we passed 2 separate lists earlier, but using dictionaries is cleaner and more readable, especially when you already have data stored as key value pairs. The beauty here is that Pandas automatically uses the dictionary keys as labels for the series, so you don't need to manually pass an index. Now, we can easily access marks by using names directly. For example, we say print series name within square brackets within quotes Charlie. Run the program and you will see 85. Perfect. Alright, let's wrap up what we've learned in this lecture. We started by understanding what a Pandas series is. It's a one-dimensional labeled array that can store numbers, strings, floats, or even Python objects. Then we created a basic series using a list of numbers, and we saw how Pandas automatically assigns numeric indexes starting from 0. Next, we learned how to access elements using both numeric indexes and custom labels when we define them ourselves. This makes working with data much more intuitive. We also explored how to create a series from a dictionary, which lets us directly map keys to values. For example, student names to their marks. After that, we performed several operations on a series, calculating the total, average, total, and highest values. By now, you should have a solid understanding of how a Pandas series works, how to create it, label it, and perform useful operations on it. Thanks for watching. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to practice Pandas series with multiple exercises. These examples will help you understand how to create, modify, and analyze data using Pandas series. Let's open PyCharm and create a new Python file. Right click on the Pandas folder, choose new, then Python file. Let's name it series_exercises. Inside this file, the first thing we need to do is import pandas. We type import space pandas space as space pid. Let's start simple. We'll create a pandas series of 5 fruits: apple, banana, mango, orange, and grapes. Let's type series_fruits equals pd.series. Within parentheses, pass a list of strings: apple, banana, mango, orange, grapes. Now print the fruits series. We type print within parentheses series_fruits. When we run the program, Pandas automatically assigns index numbers: 0 for apple, 1 for banana, and so on. Next, let's access the series data using index. Let's type print within parentheses series_fruits within square brackets, pass the index 0. Next, copy and paste this line, changing the index to 3. Run the program and you can see the value with respect to its index. Now let's create a series of employee salaries with custom labels. We'll store salaries for 3 employees: John, Emma, and Ryan. We type salaries equals pd.series within parentheses, pass the list of values 50,000, 60,000, and 55,000. Then add index equals within brackets John, Emma, Ryan. Now print the salaries series. When we run the code, you will see John 50,000, Emma 60,000, Ryan 55,000. If we want to print Emma's salary only, we type print salaries within square brackets Emma. Run the program and you will get 60,000. Pandas also lets us create a series directly from a dictionary. Let's store scores for 4 students. Alex has 85, Sophia has 92, Michael has 78, and David has 88. To create a dictionary, we type scores_dictionary equals within curly braces Alex:85, Sophia:92, Michael:78, David:88. Now create the series scores equals pd.series within parentheses scores_dict. Print the scores series. Print series name scores. Run the program and you will see the names as labels and their respective marks. If we want to know Michael's score, we type scores within square brackets Michael. Run the program and you will see 78. In this exercise, we are going to learn how to perform mathematical operations on a Pandas series. Let's imagine we have the marks of 4 subjects: 60, 70, 80, and 90. We'll create a Pandas series called marks and store these values inside it. Once the series is ready, let's add 5 bonus marks to each subject. We type print within parentheses and inside quotes, say after adding bonus marks colon, followed by a comma, then marks plus 5. When we run the program, it will display 65, 75, 85, and 95. Perfect. That's how simple it is to apply arithmetic operations to an entire Pandas series. Now let's calculate the average marks. We type print within parentheses and inside quotes, say average marks colon, followed by a comma, and then marks dot mean. When we run the program, you will see the average comes out to 75. Next, let's calculate the total marks. We type print within parentheses and inside quotes, say total marks colon, followed by a comma, and then marks dot sum. Run the program and it shows the total as 300. Finally, let's find the highest mark. We type print within parentheses and inside quotes, say highest mark colon, followed by a comma and then marks dot max. Run the program and you will see the highest mark is 90. That's how we perform mathematical operations on a Pandas series. In this exercise, we'll learn how to filter data based on conditions. Let's say we have a Pandas series called scores containing marks for 4 students. Sophia with 90, David with 88, Emma with 75, and Liam with 62. Now, we want to find out which student scored above 85. We type high underscore scorers equals scores within square brackets, then write scores greater than 85. This creates a new series called high scorers, containing only the students who scored above 85. Now print high scorers using print within parentheses high underscore scorers. Run the program and you will see the output, Sophia with 90 and David with 88. This is the power of filtering. You can easily extract specific data based on conditions in just one line of code. Hi everyone, welcome back. In this lecture, we're going to start learning about something called a Pandas data frame. A data frame is the most important and powerful data structure in Pandas. Think of it like an Excel spreadsheet or a skill table. It has rows and columns and it helps you work with structured data easily. Once you understand data frames, analyzing data in Python becomes very simple and efficient. Let's open PyCharm. Right-click on the Pandas folder, choose New and then Python file. Let's name it DataFrame_basics. The first thing we need to do is import the Pandas library. We type import pandas as pd. Here we're importing the Pandas module and giving it a short alias pd, which is the standard convention among Python developers. Let's create our first data frame using a dictionary. We'll define some student data, names, ages, and marks. We type data equals pd dot data frame. Within parentheses, pass a dictionary. Inside the dictionary, we add 3 key value pairs. The first key is name with a list of values, Alice, Bob, Charlie, and David. The second key is age with values 24, 22, 23, and 21. The third key is marks with values 85, 92, 78, and 88. This dictionary is automatically converted into a structured data frame. Think of it like an Excel table with rows and columns. Now let's print the full data frame. We type print inside parentheses data. This will display all 4 rows and 3 columns, showing each student's name, age, and marks. Let's now run the program and see the output. This is our first Pandas data frame. Each row has an index starting from 0 and each column has a name. The data frame shows 4 rows with columns for name, age, and marks. It displays the student records in a neat tabular format. The numbers on the left, 0, 1, 2, 3, are the row indexes automatically generated by Pandas. Sometimes your data frame can have thousands of rows. To avoid printing everything, we can use the head function. We type print within parentheses data.head, open and close parentheses. Run the program and see the output. By default, head returns the first 5 rows of the data frame. Since our dataset has only 4 rows, it prints all of them. If you had more than 5 rows, only the first 5 would be displayed. Similarly, we can see the last 5 rows using the tail function. We type print within parentheses data.tail, open and close parentheses. Run the program and see the output. Similarly, tail returns the last 5 rows by default. Again, since our dataset has 4 rows, the entire table is printed. Now let's say we want to print only the names. We type print within parentheses, data within square brackets, quotes around name. Now let's run the program and see the output. The output shows only the name column from our data frame. On the left you see the row index and on the right the actual names. Pandas also shows the column name and data type. Here it's an object, which usually means string data. Similarly, to print marks only, we type print within parentheses data within square brackets quotes around marks. Now let's run the program and see the output. The output displays only the marks column. This time Pandas tells us that the data type is int64, meaning integer values. Now we will see how to access multiple columns. Let's say if you want to print both name and marks, we pass a list inside the square brackets. We type print within parentheses data within square brackets, pass a list, name, marks. Now let's run the program and see the output. The output shows a smaller data frame with only two columns, name and marks. This is useful when you want to focus on specific columns for analysis. Now let's learn some important data frame properties. To find how many rows and columns we have, we use the shape attribute. We type print inside parentheses data.shape. Now let's run the program and see the output. The shape property tells us that our data frame has 4 rows and 3 columns. Next, to find the total number of values, we use print within parentheses data.size. Now let's run the program and see the output. The size property shows the total number of values in the data frame. Since we have 4 rows multiplied by 3 columns, this equals 12 values in total. Next, to get a summary of the dataset, we type print within parentheses data.info open and close parentheses. The info method gives us a summary of the data frame, total number of rows and columns, column names and their data types, non-null value counts, memory usage. Now let's see how to access rows from a data frame. Let's start by printing a single row from our data frame using the illoc function. We type print within parentheses data.lock within square brackets 0. This lock method allows us to access rows by their labels, but since our data frame uses default numeric indexes, we can simply pass the row number. This will return the entire first row because index 0 corresponds to the first student. Now let's run the program and see the output. This output shows the first row of the data frame. We can see Alice's name, age and marks in a vertical format along with the column names and data types. Let's see how to access multiple rows from a data frame. If we want to select rows from index 1 to 2, we pass a list inside lock. We type print within parentheses data.alloc within square brackets, pass a list within square brackets 1, do. Now let's run the program and see the output. The output displays the data for Bob and Charlie together in a tabular format. Using lookup with a list of indexes allows us to fetch multiple rows easily. Next, let's learn about the illoc method. While LOC works with labels, illoc works with integer positions. This is very useful when you want to select rows based on their position, not their index labels. For example, to fetch the first 2 rows, we type print within parentheses data.illoc within square brackets :2. Let's run the program and see the output. This gives us the first 2 rows of the data frame, Alice and Bob's details. Unlike lock, here we specify the range using integer slicing. Now let's filter students who scored above 85 marks. We type high_scorers equals data within square brackets, data within square brackets, pass marks, and then greater than 85. Then print the result. Print within parentheses high_scorers. Let's run the program and see the output. This output shows only those students whose marks are greater than 85. In our dataset, that's Bob and David. Pandas automatically filters out all other rows. Now let's add multiple conditions. For example, let's find students who scored more than 80 marks and are younger than 24 years. We type filtered underscore data equals data within square brackets within parentheses data within square bracket marks greater than 80 ampersand within parentheses data square brackets age less than 24, then print the result. Print within parentheses filtered underscore data. Let's run the program and see the output. Here Pandas applied two conditions together using the AND operator. The result includes only Bob and David because they meet both conditions. Next, let's sort the data frame by marks in descending order. We type sorted underscore data equals data dot and call the method sort underscore values within parentheses call the property by equals within double quotes marks comma call the property ascending equals false. Then print the result. Print within parentheses sorted underscore data. Let's run the program and see the output. The output shows the data frame sorted by marks from highest to lowest. This is very useful when ranking students or analyzing top scorers. Finally, let's generate a quick statistical summary of the dataset using the describe method. We type print within parentheses data.describe open and close parentheses. Run the program and see the output. Count shows total rows. Mean is the average value. STD is the standard deviation. Min and max show minimum and maximum values. 25%, 50%, 75% are percentiles for deeper insights. Now, let's learn how to add a new column to a Pandas data frame. We'll take the same data set of students that includes their name, age and marks. Our goal is to create a new column called grade based on each student's marks. Now let's add a new column called grade. This column will assign a grade based on each student's marks. For every student, if the marks are greater than or equal to 90, the grade will be A, otherwise the grade will be B. To achieve this, we are going to use a list comprehension. Let's type the code data within square brackets grade equals square brackets double quote A if marks greater than or equal to 90 else double quote B for marks in data marks end of square brackets. Here is what happens step by step. First, we loop through each student's marks using for marks in data marks. This goes through all marks one by one, 85, 92, 78 and 88. Next we check the condition A if marks greater than or equal to 90 else B. If the marks are 90 or more, the expression returns A, otherwise it returns B. The final result is a list of grades B, A, B and B. We then assign this list to a new column called grade inside our data frame. Once the grade column is added, we print the updated data frame to confirm the changes. Print data. Now let's run the program and see the output. In the output, we can see that the grade column has been added to the data frame. Note that Bob has a grade A because his marks are 92. All the other students received a grade B since their marks are below 90. Perfect. Now let's say Bob's marks were recorded incorrectly. Currently, his marks are 92, but we want to update them to 95. To do this, we use the Lakshya property in Pandas. We write data.lock inside square brackets 1 comma within double quotes marks equals 95. Here is what's happening step by step. The locker property is used to access a specific row and column by their labels. Row index 1 refers to Bob. Within double quotes, marks refers to the column we want to update. Finally, we assign the new value 95. After updating, we print the data frame to confirm the changes. Type print data. When you run the program, you will see that Bob's marks are now updated to 95. Next, let's say we no longer need the grade column in our dataset. To delete it, we use the drop function. We write data.drop inside parentheses, double quotes, grade, comma, axis equals 1 and in place equals true. Inside the drop function, we pass the column name grade. We set axis equals 1, which means we are deleting a column, not a row. And we set in place equals true. So the original data frame gets updated directly. After deleting the grade column, we print the data frame again. Print data. Let's run the program. You can see that the grade column is no longer part of the dataset. Now suppose we want to delete the row with index 2 which belongs to Charlie. Again we use the drop function. We write data.drop inside parentheses 2 and in place equals true. Here the number 2 represents the row index of Charlie's data. By setting in place equals true, the row is permanently removed from the data frame. After deleting the row, we print the updated data frame. Print data. Let's run the program. You can see that Charlie's record has been removed. Now let's learn how to merge two data frames in Pandas. Merging data frames is very similar to joining tables in SQL. It allows us to combine information from two different datasets into one based on a common column. Now let's create another data frame called data_2. This one will store the names of some students along with the cities they live in. For example, Alice lives in New York, Bob lives in Chicago, and David lives in Boston. Notice that Charlie's name is missing from the second data frame. So we will see later how Pandas handles this automatically during the merge. To combine both data frames, we use the merge function in Pandas. We write pandas.merge inside parentheses. We pass data_2 and specify on equals double quotes name. Here is what's happening step by step. We are telling Pandas to merge both data frames based on the column name. Only the students whose names exist in both data frames will be included in the result. This is called an inner join by default. We store the merged result in a new variable called merged_data and then print it on the screen. Let's now run the program and see the output. As you can see, only 3 students, Alice, Bob and David, appear in the merged data frame because they exist in both datasets. Charlie is missing since his record does not exist in the second data frame. Hi everyone, welcome back. In this lecture, we are going to learn one of the most important topics in data cleaning: how to handle missing data using Pandas. Missing data is very common when working with real-world datasets. Sometimes you might have empty cells, unknown values, or incomplete records. Pandas provides powerful tools to detect, analyze, and handle missing values easily. Let's open PyCharm. Right-click on the Pandas folder, choose New and then Python file. Let's name it handling_missing_data. First, we need to import the Pandas library. Type import pandas as PD. Here we are importing the Pandas module and giving it the alias PD, which is a common naming convention used by Python developers. Now let's create a dataset that has some missing values. For this example, we'll use a dataset of employees, including their name, department, salary, and bonus. Type data equals pd.dataframe, open parenthesis. Inside the parentheses, we pass a dictionary. The first key is within double quotes, name followed by a colon, and the values are within square brackets: John, Emma, Sophia, Michael, and David. The second key is within double quotes, department followed by a colon, and the values are within square brackets: HR, finance, none, IT, and finance. The third key is within double quotes, salary followed by a colon, and the values are within square brackets: 50,000, 65,000, 58,000, none, and 70,000. The fourth key is within double quotes, bonus followed by a colon, and the values are within square brackets: 5000, none, 3000, 4000 and none. Close the parentheses. Now let's print the data frame. Type print, open parenthesis, the data, close parenthesis. When we run the program, you will notice that some values are missing, shown as NaN in Pandas. NaN stands for not a number and represents missing data. Now let's see how to detect missing values. Sometimes we need to check which cells are missing. Pandas provides a function called isna. Type print data.isna, open and close parentheses. Run the program and see the output. This will display the data frame with true wherever the data is missing and false wherever data is present. There is another function called isNull. It works exactly the same way as isna. You can use either of them interchangeably. Now let's find out how many missing values are there in each column. Print data.isna, open and close parentheses, .sum, open and close parentheses. Run the program and see the output. This counts the missing values for each column and shows the result. For example, in our dataset, the department column has one missing value, the salary column has one missing value, and the bonus column has two missing values. Sometimes we only need to check whether there are any missing values at all. For that, we use the any function. Type print data.isna, open and close parentheses, .any, open and close parentheses. Run the program and see the output. This will return true for columns that have at least one missing value and false for columns that have no missing data. Finally, if you want to check whether an entire column is completely empty, you can use the all function. Type print data.isna, open and close parentheses, .all, open and close parentheses. Run the program and see the output. If all values are missing in any column, it will return true for that column. In our dataset, you will see that it returns false for all columns, since none of them are completely empty. So far, we learned how to create a data frame with missing values, how to detect missing data using the isna and isNull functions, how to count missing values using the sum function, and how to check if any or all values are missing. Hi everyone, welcome back. In the previous lesson, we learned how to detect and count missing values in a data frame. In this part, we'll learn how to handle missing values properly. We'll cover three major operations: filling missing values, replacing values, and dropping missing rows or columns. Let's open PyCharm again and start fresh with a new dataset for better understanding. We'll create a dataset of products containing product name, category, price, and discount. Some of these values will be missing intentionally. Type data equals pd.dataframe, open parentheses. Inside the parentheses, pass a dictionary. For product, provide laptop, smartphone, tablet, headphones, and camera. For category, provide electronics, none, and gadgets. For price, provide 80,000, 50,000, 30,000, 10,000, and none. For discount, provide 5,000, none, 2,000, none, and 1,000. Finally, close the parentheses and print the data frame using print, open parentheses, data, close parentheses. Let's run the program and you can see the complete data frame with some missing data. Now let's focus on the discount column. For some products, the discount information is missing. Instead of leaving them as an N, we want to replace all missing discount values with 0. To do this, we use the fillna function in Pandas. Let's type data within square brackets, double quotes, discount, close square brackets, equals data, within square brackets, double quotes, discount, close square brackets, dot fillna, open parentheses, 0, close parentheses. This permanently replaces all missing discounts with 0. Now print the data frame to confirm the changes. Print within parentheses data. Now let's run the program. As you can see, the missing discounts have now been replaced with 0, making the data cleaner and easier to work with. Sometimes we only want to fill missing values for a specific column. In our data frame, the category column has a missing value for headphones. We don't want to leave it blank, so let's replace missing categories with the word unknown. We do this using the fillna function, just like we did for the discount column earlier. This ensures that every product has a proper category assigned, making the data more complete and easier to analyze. Type data within square brackets, double quotes, category, close square brackets equals data, within square brackets, double quotes, category, close square brackets, dot fillna, open parenthesis, double quotes, unknown, close parenthesis. Print the data frame to verify that all missing categories are now marked as unknown. Print within parentheses data. Now let's run the program. As you can see, the category for headphones now shows unknown instead of neon. Next, let's handle missing prices. In our data frame, the camera product does not have a price listed. Instead of leaving it blank or assigning 0, we can replace it with the average price of all available products. To do this, we again use fillna, but this time we pass the mean value of the price column. Type data within square brackets, double quotes, price, close square brackets equals data, within square brackets, double quotes, price, close square brackets, dot fillna, open parentheses, data, within square brackets, double quotes, price, close square brackets, dot mean, open and close parentheses, close parentheses. Pandas automatically calculates the average by summing up all existing prices and dividing by the count. Print the data frame again to confirm that the missing camera price is now replaced with the average price. Print within parentheses data. Now let's run the program. As you can see, the camera price is automatically filled with the average price value, making the dataset more consistent. Now let's improve the discount column. Earlier we replaced missing discounts with 0, but 0 doesn't look very informative to the end user. So instead, we'll replace every 0 value in the discount column with the string no discount. We use the replace function for this. Type data within square brackets, double quotes, discount, close square brackets equals data, within square brackets, double quotes, discount, close square brackets, dot replace, open parenthesis, 0, comma, double quotes, no discount, close parenthesis. Print the data frame again to confirm that all zeros in the discount column are now labeled as no discount. Print within parentheses data. Let's run the program and see the output. Note that the 0 is replaced with no discount. This makes the dataset more readable and user-friendly, especially when we are displaying it on a dashboard or reporting tool. Now, let's see how to remove rows containing missing values. But first, we need to recreate the original dataset so that missing values exist again. Type the same data frame code again and print it. Then type data.dropina, open parenthesis, in place equals true, close parenthesis. This removes any row that contains at least one missing value. Print the data frame to confirm that only complete records remain. Print within parentheses data. Let's run the program and see the output. As you can see, the rows are dropped from the dataset. Similarly, if we want to remove entire columns that contain missing data, we need to recreate the dataset again to demonstrate. After recreating, type data.dropna, open parenthesis, axis equals 1, comma, in place equals true, close parenthesis. Print the data frame again to confirm the change. Print within parentheses data. Let's run the program and see the output. This removes any column containing at least one missing value. Hi everyone, welcome back. In this part, we'll explore advanced techniques for handling missing values. Forward fill, backward fill. Let's open PyCharm again and create a fresh dataset to work with. Let's create a data frame representing daily temperatures for a week. Some of the temperature values will be missing. Type data equals pd dot data frame open parentheses. Inside pass a dictionary. For day provide Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. For temperature provide 30, none, 28, none, 32, none and 31. Close the parentheses and print the data frame. Type print open parentheses data closed parentheses. When we run the program and print the original data frame, we can clearly see that some rows under the temperature column show none, which means not a number or missing data. Now let's handle missing values using forward fill. Forward fill works by taking the previous non-missing value and copying it into the missing cells below. For example, if Tuesday's temperature is missing, it will be replaced with Monday's value. Similarly, if Thursday's temperature is missing, it will take Wednesday's value. Let's write the code f underscore filled equals data and call the method ffill followed by parentheses. This creates a new data frame where missing temperatures are filled with the previous known value. Next, let's print the data frame. Print f underscore filled. Let's run the program. We can see that all missing values are replaced with the value from the row above. Next, let's try backward fill. Backward fill works in the opposite way of forward fill. It takes the next available non-missing value and fills it upward into the missing cells above. For example, Tuesday's missing value will now take Wednesday's temperature instead of Monday's. Similarly, Thursday's missing value will be filled using Friday's temperature. First, recreate the original dataset to demonstrate properly. Type data equals pd.dataframe. Pass the same dictionary again. Now type b underscore filled equals data and then call bfill method followed by parentheses. This fills missing temperatures using the value from the row below. Print the data frame to confirm the update. Print b underscore filled. When we run the program, E can see that all missing values have been filled using the values from the row below. Sometimes you might not want to fill all missing values. In such cases, we can set a limit to control how many consecutive NaN values should be replaced by forward fill. For example, if we set limit equals 1, only the first missing value after a valid temperature will be filled. Any further consecutive missing values will remain unchanged. Let's type limited underscore filled equals data dot ffill within parentheses pass limit equals 1. This fills only the first missing value in each sequence, leaving the rest unchanged. Next, print it. Print limited underscore filled. Let's run the code to see the change. You can notice that for rows having multiple missing temperatures in a row, only the first one gets filled and the rest stay as NaN. Perfect. Hi everyone, welcome back. In this lecture, we're going to learn about grouping and aggregation in Pandas. Grouping is one of the most powerful features of Pandas. It allows us to group rows based on a specific column and then apply aggregate functions like sum, average, count, maximum, and minimum. We'll use a simple and relatable example. Imagine we have a company with multiple departments, several employees, and their respective salaries. We'll learn step by step how to analyze this data efficiently using Pandas. Let's open PyCharm. Right-click on the Pandas folder, choose New and then Python file. Let's name it Pandas underscore grouping underscore aggregation. The first thing we need to do is import the Pandas library. We type import pandas as pd. Next, let's create a data frame with 3 columns: department, employee, and salary. We type data equals pd dot data frame. Within parentheses, pass a dictionary. Inside the dictionary, we add 3 key value pairs. The first key is department with values: IT, finance, IT, HR, finance, IT. The second key is employee with values: Alice, Bob, Charlie, David, Yuva, Frank. The third key is salary with values: 60,000, 70,000, 80,000, 55,000, 65,000 and 75,000. Finally, we print the data frame to see the data. We type print inside parentheses data. Let's run the program. As you can see, all 6 employee records are displayed neatly in a table format. Now let's start grouping. Let's calculate the total salary for each department. To do this, we use the group by function. We type grouped underscore salary equals data.groupby within parentheses within double quotes, pass the key department within square brackets, salary dot call the sum method. This means we group the data by the department column and then select the salary column. Finally, we apply the sum function to calculate the total salary for each department. Then we print the result. Print within parentheses grouped underscore salary. Let's run the program. As you can see, the output shows the total salaries for each department. For example, if IT has 3 employees earning 60,000, 80,000 and 75,000, the total for IT will be 2,15,000. Next, let's calculate the average salary for each department. Again, we use the group by function on the department column, select the salary column, and then use the mean function to calculate the average salary within each department. We type average underscore salary equals data.groupby within parentheses within double quotes, pass the key department within square brackets salary dot call the mean method. Then print the result. Print within parentheses average underscore salary. When we run the program, we will see that Pandas automatically divides the total salary by the number of employees in each department to get the average salary. For example, if finance has 2 employees with salaries of 70,000 and 65,000, the average salary for finance will be 67,500. We can also calculate the highest and lowest salaries in each department. Now let's find the highest salary in each department. We again group the data by department, select the salary column and then apply the max function. For the highest salary, we type max underscore salary equals data dot groupby within parentheses within double quotes, pass the key department within square brackets salary dot call the max method. Let's print the result. Print within parentheses max underscore salary. Let's run the complete program. This will return the maximum salary within each group. For instance, in the IT department, the highest salary is 80,000 and in finance it's 70,000. Let's start by finding the minimum salary in each department. We again use the group by function on the department column and select the salary column. So just copy this max code and paste it here. Change the variable name and method name from max to min. Print it. When we run the program, the output will display the lowest salary in each department. For example, in the IT department, if employees earn 60,000, 80,000 and 75,000, the minimum salary will be 60,000. Now let's count how many employees are working in each department. To do this, we again use the group by function on the department column, but this time we select the employee column and apply the count function. We type employee underscore count equals data.groupby within parentheses within double quotes department within square brackets employee.count. Next, print the result. Print within parentheses employee underscore count. Let's run the program and see the output. This shows the number of employees grouped by department. For example, IT has 3 employees, finance has 2 and HR has 1. Pandas also allows us to apply multiple aggregation functions in a single line. Instead of writing separate lines of code for sum, mean, max, min and count, we can perform all these calculations in a single step. We type multi_arg equals data.groupby within parentheses quotes around department close parentheses dot salary dot agar within parentheses pass a list sum, mean, max, min, count. Here we use the aggregation function which allows us to pass a list of multiple operations. For example, we group by department, select the salary column, and inside ag we specify sum, mean, max, min and count. Then print within parentheses multi_ag. Let's run the program and see the output. Pandas will return a table showing all these values together for each department. This saves time and makes your code much cleaner. Pandas makes it extremely simple to perform powerful aggregations. Hi everyone, welcome back. In this lecture we are going to learn how to filter data in Pandas. Filtering allows us to select specific rows or records from a data frame based on certain conditions or criteria. Let's open PyCharm. Right click on the Pandas folder, choose new and then Python file. Let's name it filtering_data. The first thing we need to do is import the Pandas library. We type import pandas as pd. Here we are importing the Pandas module and giving it a short alias pd, which is the standard naming convention used by Python developers. Let's now create our first data frame using a dictionary. We'll define some employee data, including their department, name, salary, and bonus. We type data equals pd.dataframe. Within parentheses, pass a dictionary. Inside the dictionary, we add 4 key value pairs. The first key is department with values IT, finance, IT, HR, finance, and IT. The second key is employee with values Alice, Bob, Charlie, David, Eva, and Frank. The third key is salary with values 60,000, 70,000, 80,000, 55,000, 65,000, and 75,000. The fourth key is bonus with values 5,000, 6,000, 7,000, 4,000, 5,000, and 6,000. This dictionary is automatically converted into a structured data frame. Think of it like an Excel sheet with rows and columns. Now let's print the full data frame to check our dataset. We type print inside parentheses data. When we run the program, the output will look like this, period. This shows 6 rows and 4 columns in a neat tabular format. The numbers on the left, 0 to 5, are row indexes automatically generated by Pandas. Each column has a name, and each row represents a single employee's record. Let's see how to filter rows based on a single condition. We want all employees with a salary greater than 70,000. We type high_salary equals data. Within square brackets data, within square brackets, within double quotes, salary. Next add the condition greater than 70,000. Then print a high_salary. Print high_salary. Run the program and you will see employees Charlie and Frank because their salaries are greater than 70,000. Now let's see how to filter rows based on multiple conditions. So let's filter employees who work in the IT department and have a salary greater than 60,000. We type it_high_salary equals data within square brackets. Add the first condition within parentheses data within square brackets within double quotes department equals within double quotes IT. This is our first condition to filter the IT department. Let's add the second condition to filter the salary greater than 60,000. Add the ampersand symbol within parentheses data within square brackets within double quotes salary greater than 60,000. Then print it_high_ salary. Run the program and you will see Charlie and Frank, since they are in the IT department and earn more than 60,000. Now let's filter employees who work in the finance department or earn a salary greater than 75,000. We type finance_or_high equals data within square brackets. Add the first condition within parentheses, data within square brackets within double quotes, department equals within double quotes finance. This is our first condition to filter the finance department. Let's add the second condition to filter the salary greater than 60,000. Within parentheses, data within square brackets within double quotes, salary greater than 75,000. Print finance_or_high. Run the program. Here Bob and Eva are included because they are in finance, and Charlie is included because his salary is above 75,000. Now let's see how the filter using the YESIN method. The YESIN method is useful when we want to filter rows based on multiple possible values. For example, let's filter employees who belong to either IT or HR department. We type selected_departments equals data within square brackets, data within square brackets, double quotes, department.isin method within parentheses within brackets within double quotes, IT comma within double quotes, HR. Then print selected_departments. Print selected_departments. Run the program and you will see employees from IT and HR only. Now let's see how to filter using the between method. The between method is perfect for range-based filtering. For example, let's filter employees with salaries between 60,000 and 75,000. We type salary_range equals data within square brackets, data within square brackets within double quotes, salary outside the square bracket dot. Call the between method within parentheses 60,000, comma 75,000. Then print the salary_range. Print salary_range. Run the program and you will see employees Alice, Bob, Eva and Frank. Notice the salary of these employees. It's between 60,000 and 75,000. Now let's see how to filter using the query method. Pandas also provides a very clean way to filter using the query method. For example, let's filter employees from the finance department with a bonus greater than 5,000. We type finance_bonus equals data dot query within parentheses within double quotes department double equals in single quotes finance and bonus greater than 5,000. Then print the finance_bonus. Print finance_bonus. Run the program and you will see Bob only, because Bob belongs to the finance department and who has bonus 6,000, which is greater than 5,000. Perfect. Let's wrap up. In this lecture we learned how to filter data using single and multiple conditions, how to apply and/or logic in Pandas, how to use the YESIN method, between method and query method for advanced filtering. These techniques are essential for data analysis because they help you work only with the data you actually need. Hi everyone, welcome back. In this lecture we are going to learn how to sort data in Pandas. Sorting is one of the most commonly used operations when working with data sets. It helps us arrange rows based on one or more columns in either ascending or descending order. We'll cover how to sort data by a single column, how to sort data by multiple columns, how to sort data in descending order, how to sort by index values, how to perform in-place sorting without creating a new data frame. Let's open PyCharm. Right-click on the Pandas folder, choose New and then Python file. Let's name it sorting underscore data. The first thing we need to do is import the pandas library. We type import pandas as PD. Here we are importing the pandas module and giving it a short alias PD, which is the standard naming convention used by Python developers. Let's now create our data frame using a dictionary. We'll define some employee data with 4 columns: department, employee, salary and bonus. We type data equals PD dot data frame, within parentheses pass a dictionary. Inside the dictionary we add 4 key value pairs. The first key is department with values IT, finance, IT, HR, finance and IT. The second key is employee with values Alice, Bob, Charlie, David, Eva and Frank. The third key is salary with values 60,000, 70,000, 80,000, 55,000, 65,000 and 75,000. The fourth key is bonus with values 5,000, 6,000, 7,000, 4,000, 5,000 and 6,000. This dictionary is automatically converted into a structured data frame. Think of it like an Excel sheet with rows and columns. Before sorting, let's print the data frame. We type print inside parentheses data. When you run this program, it will display the original data set with 6 rows and 4 columns, showing department, employee names, salaries and bonuses. Let's now sort the employees by their salary in ascending order. We type sorted underscore salary equals data dot sort underscore values, within parentheses by equals inside quotes salary. This means we are telling pandas sort the data frame based on the salary column from the lowest salary to the highest salary. Then we print the result by typing print within parentheses sorted underscore salary. When we run the program, you will see employees arranged starting from the lowest salary up to the highest salary. Now let's sort the employees by their salary in descending order. We type sorted underscore salary underscore desk equals data dot sort underscore values, within parentheses by equals inside quotes salary comma ascending equals false. Here we have added ascending equals false, which tells pandas to reverse the sorting order, showing the highest salary first and the lowest salary last. Finally, we print the result by typing print inside parentheses sorted underscore salary underscore desk. When we run the program, it will display the data frame sorted from the highest paid employee down to the lowest paid employee. Sometimes we need to sort the data by more than one column. For example, let's sort the employees first by department and within each department sort them by salary in ascending order. We type sorted underscore depth underscore salary equals data dot sort underscore values, within parentheses by equals inside square brackets department comma salary. This means we are telling pandas first group employees by department, then sort each department based on salary in ascending order. Finally, we print the result by typing print inside parentheses sorted underscore depth underscore salary. When you run the program, you will see employees grouped by their department names. Within each department, salaries are arranged from lowest to highest. Next, let's sort the data frame based on its row index. Remember, pandas automatically assigns an index to each row starting from 0. We type sorted underscore index equals data dot sort underscore index, within parentheses ascending equals true. This tells pandas to sort the data frame based on its index in ascending order. Then we print the result by typing print inside parentheses sorted underscore index. When you run the program, the rows will be arranged in order based on their index numbers. Now let's learn in place sorting. So far, Whenever we sorted, we created a new data frame to store the results. But sometimes we want to sort the original data frame itself without creating a separate variable. We'll sort the employees alphabetically by their names and update the original data frame directly. We type data.sort_values within parentheses by equals inside quotes employee comma in place equals true. This modifies the original data frame permanently. Finally, we print the data frame by typing print inside parentheses data. When you run the program, the original data frame will now show employees sorted alphabetically by their names. Let's wrap up. In this lecture, we explored sorting techniques in Pandas step by step using a real-world dataset of employees. We started by learning how to sort a single column like salary in ascending order to arrange employees from the lowest to the highest salary. Then we reversed the order by sorting the same column in descending order to see employees with the highest salaries first. Next, we looked at sorting by multiple columns. For example, we sorted the data first by department and then by salary within each department. This is very useful when working with structured datasets where we need organized groupings. We also learned how to sort by index values, which comes in handy when you want to reset your dataset to its original order. Finally, we explored in-place sorting, where we directly modified the original data frame instead of creating a new one. This is useful when working with large datasets where memory efficiency matters. By now, you should be comfortable using Pandas sort_values and sort_index methods effectively. These techniques are extremely important when analyzing and presenting your data in a meaningful way. In this lecture, we are going to learn how to read CSV files using Pandas. CSV files, also called comma-separated values files, are one of the most common ways to store tabular data. We'll cover everything step by step: how to read a CSV file into a data frame, how to set an index column, how to read only selected columns, and how to read large files efficiently. Let's open PyCharm. Right-click on the Pandas folder, choose New and then Python file. Let's name it pandas_read_CSV. The first step is to import the Pandas library. We type import pandas as pd. This will let us use all Pandas functions easily by calling pd dot. Before reading a CSV file, let's create one so we can practice. Right-click on your project folder and create a new file. Name it employees.csv. Inside this file, add the following sample data. Now save the file. To read this CSV file, we use the read_CSV function from Pandas. Let's see how to read the CSV file. Let's type data equals pd dot read_CSV within parentheses, pass the file name within double quotes employees.csv, then print data. When we run the program, Pandas loads the file into a data frame and displays it in a neat tabular format. Note that by default, Pandas automatically assigns numbers as row indexes. Perfect. Now let's see how to set a custom index column instead of the default one. For example, let's set the employee column as the index. Let's type data equals pd dot read_CSV within parentheses. File name equals employees.csv, comma, index_col equals within double quotes employee. Then print the data frame. Type print inside parentheses, pass data. Let's run the program and see the output. Now the employee column becomes the index of the data frame, making it easier to access data by employee name. Perfect. Sometimes we don't need all the columns from a CSV file. Let's read only employee and salary. We type data equals pd dot read_CSV within parentheses. File name equals employees.csv, comma, user calls equals within square brackets within double quotes employee comma within double quotes salary. This displays only two columns from the CSV file, making the data frame smaller and easier to work with. Next, print the data frame. Type print inside parentheses past data. Let's run the program. You can see here that only the employee and salary columns are selected from the CSV file. Perfect. If you are working with a very large CSV file, loading the entire dataset at once may consume a lot of memory. In such cases, we can load the data in chunks. We type for each chunk in pd dot read underscore CSV within parentheses, file name equals employees dot CSV, comma, chunk size equals 2, then print chunk. This will load 2 rows at a time, making it easier to work with large files efficiently. Next, let's run the program. This reads the CSV file 2 rows at a time and prints each chunk separately. Hi everyone, welcome back. In this lecture, we are going to learn how to write Pandas data frames to CSV files. This is one of the most common tasks in data analysis. After processing your data, you will often need to save it for later use or share it with others. We'll cover everything step by step. How to write a data frame to a CSV file, how to customize the file name and location, how to include or exclude the index, how to change the separator, and how to append data to an existing CSV file. Let's open PyCharm. Right click on the Pandas folder, choose new and then Python file. Let's name it pandas underscore write underscore CSV. First we import the pandas library. We type import pandas as pd. Let's quickly create a sample data frame to work with. Let's type data equals pd dot data frame within parentheses pass a dictionary. Inside the dictionary, department equals within square brackets IT finance IT HR finance IT, employee equals within square brackets Alice Bob Charlie David Eva Frank, salary equals within square brackets 60,000 70,000 80,000 55,000 65,000 75,000. Finally, print the data frame by typing print inside parentheses data. When we run the program, we'll see 6 rows and 3 columns. Now let's save this data frame into a CSV file. We use the _CSV function. We type data dot _CSV within parentheses, pass the file name within double quotes employees underscore saved dot CSV. When we run the program, you will see a new CSV file named employees underscore save.csv created in your project folder. Open this CSV file and you can see that the data is successfully saved in the CSV file. Perfect. Note that by default, Pandas writes the row index into the CSV file. If you don't want the index column, we pass an extra parameter called index equals false. Let's see how to do it. Copy this piece of code and paste it here. Next, let's make the index false. So here, call the attribute index and set it to false. Let's run the program. Now, when you open this CSV file, you will see only the original columns, department, employee and salary, without the extra index column. Perfect. Sometimes we want to use a different separator instead of a comma. For example, we can use a semicolon. Copy this piece of code and paste it here. Next, let's make the change to use a semicolon separator. So here comma and then call the attribute equals within double quotes semicolon. Let's run the program. Next, open the file. You can see that the columns are separated by semicolons instead of commas. Sometimes you may want to add new rows to an existing CSV file without overwriting it. Now let's create new employee data and append it to the existing CSV file. We create a new data frame called new_data containing 2 additional employees, George and Hannah. We type new_data dot to_CSV within parentheses within double quotes employees underscore saved dot CSV, comma, mode equals, within double quotes, comma, header equals false, comma, index equals false. This appends the new data at the end of the existing CSV file. Let's run the program. Open the CSV file and confirm the change. The first 6 rows are from the original dataset. The last 2 rows are newly added employees. We used mode equals A to append data instead of overwriting the file. We set header equals false to avoid duplicating the column names. Perfect.